Good morning, everyone. My name is James Lane. I'm a front-end graphics developer, and welcome to this presentation on improvements that we've made to labeling and graphics. And this is particularly for the front end. And in particular, I'm going to be looking at improvements such as we've now made it so that label typesets to LabeledGraphicsBox, and this improves and provides better layout and the resizability of these labeled graphics. We've added an alignment option to graphics. So when you've got extra space around graphics, it'll provide you control of how the graphic is spaced within that. We have improved rendering of curves by making the tight range or the plot range fit tightly around the curves instead of just fitting around their control points. We've reduced Z-fighting and other artifacts by implementing a technique which preserves precision in the depth buffer, and this is at no extra memory or performance cost. And we'll also be looking at how rendering of surface appearance is massively faster since it now works with depth peeling. These are just some of the improvements and new features we've implemented. Please attend John Fultz's front-end overview talk or Yutsu's customized rendering with GLSL to learn more about other improvements that we've made to the front end in terms of graphics. Previously, when you would typeset or when you would evaluate a labeled of a graphics or graphics 3D, it would evaluate to this very complex expression. But now in sorry, wrong slide. Now if you evaluate or typeset labeled, it will typeset to LabeledGraphicsBox, and just to be able to disable or enable this, we've provided a wrapper labeled uses LabeledGraphicsBox. So if you do want to disable this, you can always use that wrapper and set it to false, and then typesetting will go to that very complex expression. Or if you set it to true, it will use LabeledGraphicsBox under the hood for labeled expressions. So why would we do this? One of the advantages of LabeledGraphicsBox is that previously, if you had a labeled expression of graphics, you could only select the graphic, but with LabeledGraphicsBox, you can select the entire construct and you get these resize handles, and you can resize the entire construct as well as resizing the graphic. The other advantage that LabeledGraphicsBox gives is it goes to lengths to try to keep the labeled and the graphics tight to each other without admitting extra space around the graphic. So previously in this graphics row, if you enlarge this, you'll see this extra space creeping in, and that's very undesirable. With LabeledGraphicsBox, if we do that, it enlarges the graphics boxes, it doesn't admit extra space, and it keeps things tight. So that's great. To get this to work with labeled now and to typeset to labeled, we've made sure that LabeledGraphicsBox fulfills all the options and the various forms, for instance, of content size and image size. So when you do labeled graphics and you say content size full, it'll fill the screen, and that will just be using a LabeledGraphicsBox under the hood. This also works for labeled graphics in a pane. It works with all the different various sizing forms, like scaled to 50% of the window size, or in this case, the scaled of 0.5 here will use 50% of the pane. And it works with named sizes and all these various forms. One thing to be aware of is that if you now with labeled and LabeledGraphicsBox, you can specify both a content size and an image size. If you, and in these cases, content size is going to win. So in this example, here's a massive image size, but when you evaluate it, we can see the content size ones. So the content area refers to the area where the graphic typically resides, and that's apart from the label. So that is set to 150, and then the labels come in tight around that. We've also made sure that LabeledGraphicsBox works with the different framed options of labeled. So just to distinguish what that's about is if you consider framed versus the frame option of labeled, if you were to evaluate framed of labeled, it'll wrap the labeled graphics box in a frame box. If you were to use labeled graphics box and specify the frame option, you would, and you looked at the typesetting of that, you would see that the frame box wraps the inner graphic. And the difference between those two is when framed wraps the whole expression, the label and the graphic are wrapped. When you use frame as an option of labeled, it just wraps the graphic. And so we made sure this works in a consistent way with what went before and how labeled worked before. And just now with framed, the way we got that to work was we allow frame box to wrap the graphics box, and then all the options such as frame margins, and frame style, they carry through to that frame box, and you have the ability to use all those options with labeled graphics box. In 14.3, labeled graphics box allowed us to resize the graphic arbitrarily. You could change the size of or the image size to whatever you'd want, and this seemed to work nicely, but we found that this can admit extra unwanted space above and below the graphic. In this case, here and here, we can see extra space coming in above the graphic, below the label. In this case, with a label on the left, we can see it runs over the side, and in these examples, you can quite easily have this extra space creeping in. So in 15, we've changed that behavior to so that labeled graphics box resizes more like a typical graphics box does, trying to keep its aspect ratio the same. So now if we resize, we can make it bigger and smaller, and this resizes the same way a graphic would resize. And it ensures that no extra space creeps in on the sides or the top or the bottom, irrespective of how we size it. And this also works when the labels are on the left or the right. We try to keep some sense of the aspect ratio and without admitting extra space, and trying to keep jumping down to a minimum. In these examples, we can see there's some jumping. This is wrap text. So as the text jumps to a new line, there is some change in size, but it's not significant. Another thing to notice is in these examples, the labels could extend beyond the graphic, but we've now also constrained the size of the labels to stay within the graphic size. And this is appropriate for most graphics, like in LaTeX, and the graphics typically dominate and the labels fall in underneath the space available. We have introduced an alignment option for graphics. So previously, if you had a graphic and, for instance, the image height was larger than the graphic could size itself within the specified image size, you'd end up with this extra space outside of your graphic. And now with the alignment option, or previously as well, these graphics would always be centered in that image size space. But now we've implemented an alignment option, and in these cases, you could say, for instance, I want my graphic to be aligned to the top of that space. It must be aligned so that my baseline and my axis or my baseline is aligned or you could specify that it must be aligned to the bottom. In the case where the graphic is wider, or the space available for the graphic is wider than the graphic itself, you could say, I want my alignment to be on the left or centered or right. And so this alignment option takes all the typical values that alignment can take. You can even specify a custom alignment where it's a number, and where -1 would represent on the left, 0 would represent in the center, and right, +1 would represent the center. And then you can specify these kind of custom float type values to get a custom placement of your graphic within the available space. We had a request or a question about the plot range and the automatic plot range determination of certain curves. So if you had a curve in, say, 14.2 and you evaluated that, you'd have a lot of extra space around the actual curve. And if you looked at the absolute options of that and you looked at the plot range, you'd see that it's using the control points to determine the plot range. In 14.3 and 15, that plot range is now tight to the curve. So it uses only the actual control, only the sample points along the curve to contribute to the plot range. So we now end up with a tight plot range around curves. So the one negative of this is that if you do want to edit those control points, they can end up off screen, and that is something we're still working on, where when we go into editing mode, we'll allow the plot range to adjust while you're editing to include the control points. Z fighting is an artifact that typically shows up in 3D graphics. Here's an example from a game demo that one of our front-end developers put together. And in this example, you'll notice all these artifacts bleeding through the different faces of the different triangles that have been rendered here. Here's another example that we encountered where there's a house, but the edges of some of those primitives are bleeding through as you rotate and move around the graphic, which is very nasty. So we implemented a technique called reverse Z, which helps to improve precision in the depth buffer. It's invoked with or turned off with this method option, method reverse Z. This is a graphics method option. And if we set that to true, in this example, you'll see that those edges and bleeding through are gone now, which is terrific. Here's the other example, Graphics 3D. We've got this method option, and setting that to true, we can see that those artifacts disappear and the edges no longer bleed through. So the details of this, this only works for perspective projection. If you're doing orthographic projection, this won't make a difference. But under perspective projection, what happens is there's a linear divide, which helps to calculate the depth and normalize depths. And basically, this technique counteracts that. So when you divide by 1/z, it's a nonlinear perspective divide, and because floating points have more precision as well, closer to 0, we end up with depth values bunching up or having more precision close to the near plane. And so things that are far away, they lose precision. So anything within this range could get confused with that value or that value in this graph. But with reverse Z, what happens is we swap the 1 and the 0 depth values that we project to, and what happens is now the high precision in the floating point ends up closer to the far plane, and this counteracts because floating point numbers have a kind of a logarithmic behavior. It counteracts that and ensures that the depth values end up more uniformly sampled across the depth range. And so this technique doesn't have extra memory costs or performance costs. One thing to say, this is the default for our metal and DirectX renderers. It can be turned off by saying method reverse the false for those. We haven't implemented this for OpenGL, or we're busy implementing it, but OpenGL on some systems, it's not guaranteed that this will work. When we render something and we specify that we want to use a custom OpenGL shader, so if we want a surface appearance, and this is typically if you use material shading or toon shading, and there's opacity, what happens is, or these expressions evaluate and they produce a surface, or they typeset to a surface appearance, which causes us to invoke a custom GLSL shader. And what happens though when transparency is involved in these expressions, these surface appearance haven't worked with depth peeling in the past. And so we have to switch over to rendering these scenes with a BSP tree. And if you look at the frames per second at the top here, you'll notice as I drag this, it's very slow. It's like 1, 2 frames a second, and it's really stuttering. We also, if we want to use the different depth peeling method options, such as one layer, if you wanted to see the second depth layer, the color values or the depth values, that hasn't worked in the past. But we've now made surface appearance work with depth peeling. So now if we render that and we rotate this, it's fully interactive. You can see this is over 30 frames a second, and that's much faster. Also, we get the benefits of being able to have surface appearance shaders, be able to pull off the color or the depth layers for that are peeled as we render this. And that works with toon shaders and all the various surface appearance shaders. We still have to implement it for the 2D cases, but in 3D, this is working now. So this brings this talk to end. So basically, we've just looked at how we've improved and improvements we've made in the front end. Labeled graphics being under the hood of labeled of a graphic now helps us to have better layouts and keep things tight. We've added the ability to align graphics, which helps to control how graphics are placed when there's extra width or height around the graphic. We avoid extra empty space around curves, and we've reduced Z fighting artifacts by implementing the reverse Z depth precision improving technique, and we've accelerated rendering of surface appearance with transparency by getting it to work with depth peeling. Just to say, I forgot to share, to get depth peeling working with surface appearance, typically you could go to system resources and look at any of the shaders like the Fong GLSL shader, and in that you'll see we've added, or to get this to work in your shaders, you'd add a define that's WL enabled depth peeling. You'd specify the uniforms that you want, and you'd add this little snippet of code which actually is the depth peeling discard function. And then in your main fragment shader, all you'd have to do is just say depth peeling discard, and that would take care of it. And that is the talk. I'll try to take some questions now. Let's see what the questions are. Thank you as well so much for attending this talk and listening. Okay, first of all, one question says, nice is look preserve accurately if then copied into a PDF file. Let me So one of the questions says, is the look preserved accurately if copied into PDF files? Is that if it's for surface appearance, I'm not sure. I think we might make that a bitmap. And so if we generate a bitmap for that, it would be preserved. Next question is syntax suggestion. Plot range full spline include control points. Okay, so to be able to control whether we want to display or use the plot range set to the control points or the actual sample points on the curve, that's a very good suggestion. I'll follow up on that so you can control it. Very good suggestion. The next question is concerning graphics in 15. Does the scaled option now allow me to reverse the coordinate system? For example, to convert a polar plot scale system so that 0 is at the north position and the ticks advance in a clockwise fashion. Hi, Andrew Chase. Thanks for asking that question. I do not know. I think it won't. The polar plots and those systems typically have their own scale in those typeset expressions and functions. I don't think they correlate directly to this. What it might do is, though, it might open the door for those functions to achieve that. And there's the final question here is also for polar plot scaled question. Does that also allow me to use drop lines that are adjusted to the scaled option I specified? If I click at the 6 p.m. location, will I see it showing at this? So I do not, unfortunately, know the answer to that question. Brett Champion would be a good person to ask. Brett would probably be the right person to ask. If there are no more questions, thank you again so much for coming to this talk. And I hope this has been helpful to you and that you enjoy the rest of the conference.